Hi Matrix, if you just tuned in, remember you didn't miss a lot of stuff. You are just right on time. And also, if you have anybody who's not yet tuned in, just remind them to please tune in to our show, which is from 5 to 6 p.m. proudly sponsored by Liberty. So I'd like to also send a shout out to Liberty for sponsoring us. Right about now, we're gonna go into a question that was sent through to us by Kanye.
Hey guys, my name is Kanyisele Mhlongo and I would like you to help me with this question.
Oh, thank you, Kanye, for sending that question. Guys, remember to send more questions if you have any other questions through our Facebook line and our WhatsApp line. There's also a TV to be on, so you might be next, which is the courtesy of Tenfold. So just send more questions if you have any. Also remember to download our app. So let's have a look at what Kanye wanted us to actually deal with. The first question the question that she sent to us says the points A, B, and C are the vertices of triangle ABC. Before we go anywhere, I'd just like to actually draw this diagram and actually see what triangle it looks like, because I feel that might be useful when we're trying to solve this triangle. So I can just draw my rough Cartesian plane there. It doesn't really need to be to scale. The point A is 2 and -5. So I know 2 and -5 will be somewhere here. So that's my point A. And then the second point is 2 and 3, so it means it's on the straight line with the point A, but it is there by 3, so it's somewhere up there. And then the last point will be C, which is -4 and 3. So this is 3, that is 3, it means they're also in a straight line with one another. So that is going to be there. Then that's my C. Now, my diagram will be looking like this. Okay. Now, looking at this diagram, you can definitely see that since these are on the same straight line and they are parallel, this line rather is parallel to this one, and this one is parallel to the x-axis, it means that this is a 90 degrees there. So this is a right-angled triangle. So I haven't really done anything here. I was just drawing the diagram for you so that you can see. Please, I'm not answering the question. I'm just interpreting what the question says. So it is important, one, to try and visualize what the question is saying if there is no diagram, and then go into solving it. So the second step will then to read the question. It says, calculate the coordinates of the point which is equidistant. Now I'm seeing some big words that they are mentioning here. Which is equidistant from the 3 vertices of a triangle. Now quickly, let me just remind you quickly, guys, about your Euclidean geometry that you should be knowing by now. Since this is a what do you call that, a right-angled triangle, if I was to draw a circle around it, this line, which is AC, according to my diagram, will be the diameter of that particular circle. Why? Because it subtends a 90 degrees on the circumference, which will be at point B. Therefore, if I find the midpoint of this diameter, which is AC, it means I've found the center of the circle, and the center of the circle will be equidistant to all the points on the circumference of the circle. Then will mean that from that point to any point on the circumference, it will then be our radius. So that's one thing you also need to remember. So that's the approach that we're going to be taking to try and do this question. Now, it says calculate the coordinates of that. So it means what I just said to you guys is I need to find the midpoint of this line here. So I need to find the midpoint here. If I find that midpoint, then it will mean that the distance from there to there, and this distance here, and also this distance here will be equal to each other, because then I will have an imaginary circle around that particular thing, which I didn't really draw to scale, but I hope you guys can actually get the idea of what I'm talking about. Now, let's just look at what we can do then. It says M, let me use the scalar, M of AC will then be equal to, remember the midpoint formula, XA plus XB plus XC divided by 2, and then YA plus YC all divided by 2. Then this will then be equals to my XA, remember we are given to be 2, then plus my XC is minus that, so it's minus 4, divided by 2, and then I have ya there will then be a negative 5. Then my my yc will be plus 3 divided by 2, and this will be equals to 2 minus 4 is negative 2. So here I'm gonna have negative 2 over 2, and then also I'm gonna have negative 5 plus 3 will then be 2 divided by 2. Then lastly, my coordinates will be, oh, look at me making a silly mistake. Remember, negative 5 plus that is a negative there. So it's going to be negative 1 and negative 1. So this will then be the coordinates of the point that they want. So guys, please, if you make mistakes, it means you are still human. So, but stay away from making mistakes because they're going to cost you your marks. Since I'm making a mistake, it means you must learn from that particular mistake. So remember, guys, what the question wanted you to do is find the coordinates of a point equidistant. One equidistant means it must be at the same distance from the point to any point from there. Now, looking at this triangle that we have, it's a right-angled triangle. That means the midpoint of the line that subtends the 90 degrees will then be the midpoint of a center that circumscribes that particular triangle that we have. So you guys please need to look at that. So quickly, please just look at this particular question, or rather this part of the diagram. Given that this is 90 degrees on that, you guys will normally call this the issue of a semicircle. So that's one thing that I want you please to look at. So that's what we are trying to say. Right about now, you guys, we're gonna go into a theory video, and then I'll be back with more questions. Just remember to tune in, and also tell your friends to tune in. Anybody who's not watching while you are watching, just tell them quickly to tune in because they haven't really missed much. There's still a lot more that we're gonna be doing with you.
The general equation for a circle with the center at the origin and radius r is x squared plus y squared equals r squared. Here is a circle with the equation x squared plus y squared equals 16. It is centered at the point 0 and 0 and has a radius of 4 units. You can take any point P on the circumference and make a right-angled triangle using the radius. That means that you can use the theorem of Pythagoras to calculate the radius of the circle using the x and y values of point P. What happens when the circle does not have the center at the origin 0, 0? Consider a circle on the Cartesian plane with the center at A, B, with a radius of r units. So the circle is the set of all points x, y that are r units away from the center A, B. To find the length of the radius, we can use Pythagoras again. This is actually the same as using the distance formula that you know. If you make a right-angled triangle using r as the hypotenuse, you can work out the lengths of two sides of the triangle. The length parallel to the x-axis is x minus a, and the vertical length is y minus b. So the radius squared equals x minus a all squared plus y minus b all squared. Note that if a is 0 and b is 0, then the equation will be r squared equals x squared plus y squared, which is the equation of a circle with center 0, 0. This equation is very useful. We can easily see that AB is the center of the circle and R is the radius. In grade 12 analytical geometry, we have established that the equation of a circle centered at A, B with radius R is R squared equals x minus A all squared plus y minus B all squared. Now we look at tangents to circles. Remember that a tangent is a line that touches the circle at only one point, the point of contact. A tangent to a circle is perpendicular to the radius of the circle at the point of contact. A tangent is a straight line, so you can find its equation using a point and the gradient. In the diagram, CBD is a tangent to the circle with the center A. CBD is perpendicular to the radius AB, so the gradient of the tangent M subscript CD times the gradient of the radius M subscript AB is -1.
You guys, are you back? I'm back. Remember to also tell your friends to please tune in so that they can see the magic happening in mathematics. Welcome back to the show. We'd also like to also send a shout out to Liberty for sponsoring us. Guys, there's a lot that maths has to do with in life. Remember, there's two types of questions in analytical geometry that you can see, as the video was telling you just about now. One, you can have a center that is at the origin, and you can have a center that's not at the origin. The difference between the two is the center is 0 and 0. The center is something else this side. So just have a look at such things. Right about now, we're going to go into a question that was sent through to us by Lebang.
Hi guys, my name is Lebang Tobana. Can you please assist me with these questions?
Thank you, Lubang, for that particular nice question that you just sent. Remember, guys, you can also send more of your questions if you've got any through our Facebook line and also our WhatsApp line. Remember, mostly advisably will then be a video, a selfie video where you show us your face, you tell us your name, and also you show us what question you actually want us to assist you with. You can send any more questions that you have from past papers. Next week, we're going to be doing past papers with you. We're wrapping up analytical geometry today and tomorrow. And also, I'd like to remind the parents out there to say, please, go and apply for your learners that are going to grade 1 and that are going to grade 8, because the polls were open Monday the 20th. So just go and apply for them. But for now, let's have a look at what Lebang wants us to assist her with. The question says, a circle with center M cuts the x-axis at point B, which is 6 and 0. Then determine the equation of the circle. Now, equation of the circle. There's two things you need in an equation of a circle, as the theory video was just saying right now. We have a center, therefore it is not at the origin. We are given a center, which is the first thing we need whenever we're dealing with an equation of a circle. The second thing we need will be the radius of that particular circle. So here we are given an advantage, one, which is the center. We just need to find what the radius is of this particular circle. So let's just have a look at that. Now, I know for a fact that this point here is the center, and I know that this point lies on the circle that we are given. So it means the distance from here, so the distance MB will then be equal to the radius of this particular circle that we are talking about. So just to find the distance quickly, I will then say it's going to be XB minus XM all squared plus YB minus YM all squared. And then this will then be equals to X at B is 6 minus M at that is 2. And then squared plus Y at B is 0 minus Y at M is a -3. So it's going to be -3 there. Remember, please, guys, you need to pay attention to detail. Like these mistakes, like what I have here, you guys normally make mistakes where you just write one negative because you're not really paying much attention and nerves are dealing with you. So please, just pay attention to those details because they can cost you your marks. Now, 6 minus 2 will then be a 4. So I have 4 squared plus a negative multiplied by a negative is a positive. Therefore, I have 3 squared, which is then equals to a 25, because this is 16 plus 9. Now, given this, I don't need to square root this, because remember, in an equation of a circle, I have r squared, not just r. So I don't really need to square root this to find what the actual radius is. I just needed the radius squared. Now, going into the actual equation of a circle will then be given by x minus a all squared plus y minus b all squared is equals to r squared. Now remember where these two are our center of the circle. So these two are the center, and that's the radius. Now given that this is the radius, we just spoke about it, it's the length mb squared. Now let's substitute what exactly we have. This will then be x minus the center we are given to us as 2 and minus 3. So this is minus 2 all squared plus y plus 3 all squared is equals to mp squared. We just found it to be equal to a 25. Easy peasy lemon squeezy. The next question says, determine the equation of the tangent to the circle at B. The theory video just told you right now, to find an equation of a tangent, you need two things. The gradient of the tangent. Number two, you just need at least a point to find the value of C. Now, a tangent to a circle, from your Euclidean geometry, you know that it is perpendicular to the radius of that particular circle. So it means if I know the coordinates of the radius, or the coordinate that maketh a radius, I can then find the gradient of that multiplied by the gradient of the tangent, and then say equal to minus 1, because they have a perpendicular relationship with each other. So that's one thing to consider when you are dealing with this question. Now I know that my center, which was given to me, was 2 and negative 3, and then I know that I have B, which is 6 and 0. Therefore the gradient of MB multiplied by not BB but MB multiplied by the gradient of the tangent will be equal to a negative 1. Why? Because they are perpendicular to each other. Therefore the gradient of MB will then be, remember these are my 2's, those are my 1's, so it will be 0 change in y plus 3 divided by 6 minus 2, so 6 minus 2 multiplied by m of the tangent, which is equal to negative 1. Then here what I have is 3 over 4. So I have 3 over 4 multiplied by m of the tangent is equal to negative 1. Then lastly, m of the tangent will then be equal to, you tip and times this so that you can get it that side. So I must just writing it down for you here, multiply by 4 over 3 just to get rid of it. Therefore it will be negative 4 over 3. And that will be my, what do you call that? That will be my gradient. Now, I just mentioned that the theory video and myself have told you there's two things. One, gradient. Two, you need a point, which we call the tangency point. So the tangency point here, we are told it's B. So you can substitute the coordinates of B to find the value of C. So I'll have y is equals to mx plus c. I was given this as negative 4 over 3, or rather I found it to be negative 4 over 3, then y. Now using the coordinates of b, the coordinates of b were 6 and 0, so it's going to be 0 is equals to negative 4 over 3 into 6 plus c. 6 multiplied by that will then give me, this goes twice there, it goes once, therefore it will then be negative 8. So I'll then have my c as equals to a positive 8. And then remember to conclude, please. Therefore y will then be equals to negative 4 over 3x plus 8. Easy peasy lemon squeeze. Now there were two things that we wanted you guys to please do for us here. One, to find the equation of a circle. We gave you already the center, so that was a bonus for you. Just needed to find the radius of that. The second question was a tangent to the circle. Tangency point will then make the tangent to be perpendicular to the radius of that circle. If I know the gradient of this, I then know the gradient of this, because the product of those two gradients must be equal to -1. And then also from there, I just need the C value, which is the y-intercept. To find that, I need at least a point on the graph. So please, guys, remember to download our app. After downloading our app, there's also a lot of videos that you can see there that you can always talk to us about. And also there's a live stream option that you guys can consider if you can't watch us on TV. And then also, when you send more questions and we like your video, you have an advantage of winning a 19-inch screen TV courtesy of Tenfold. Right about now, we're gonna go into an ad break, and then I'll be back with more questions.